Well, where I left off with this was I was in the process of doing a complete teardown of the whole thing. I just started taking more and more parts off and then realized, well, in for a penny, in for a pound, I might as well just cut to the chase and tear this thing completely down. I was getting to the point where I was getting ready to get the cylinder out. I was getting kind of frustrated with how filthy everything on this thing is. So I finally decided to just throw it in the parts washer and give it a cleaning. And there's still some crud in here and everything, but I got a lot of the heavy stuff off. So I've gotten to the point now where I was taking the bolts out of the bottom here. 4 bolts in the bottom. And as I took the bolts out, I noticed on the threads of the bolts a band of red. It almost looks like they used a red Loctite to hold these in. Now, that's kind of odd. I think it might be just a Loctite that happens to be red in color. I don't think it's actually red Loctite. I think it's the thread locking compound that happens to be red, because red Loctite requires heat for removal, and obviously if you tried to heat this up, you'd melt the plastic. So I think it was just some kind of thread locking compound. Point is that these are in there. They're hard to get started. They're Torx. I got 3 out of 4 out, and then I couldn't get this last one, the bit, to grab any longer. And then I looked at the bit much more closely, came to realize that literally the end of that Torx bit is twisted. I was putting enough torque on there to actually cause this Torx bit to twist. And this is the correct size. I'm pretty sure it was a T27. So I have, I believe, damaged the head on that one a little bit. So now my problem is getting this out. So I'm going to try what I probably should have tried before I ended up damaging that bit so badly. I'm going to try a impact driver. So I think I have one more Torx bit left of that size. So this is an impact driver. And the way this works is you hit it on the back with a hammer, and it causes this to drive in, and also it gives it torque. It turns as it drives in because of the way that it's the mechanism inside works. So this has got an adapter on it right now that I can't use. That's 3/8. That gives us 1/4 inch. This is a 1/4 inch adapter, but I don't know if that's going to fit down the... Yeah, it does. Okay, so wish me luck. Well, that worked. Got the last bolt out. So anybody who's watching this and is wondering about how to take one of these apart, these 4 bolts in the bottom here obviously are crucial, but also this rearmost stud right here actually goes through the back side of this, actually threads into the long block assembly. So you're not going to be able to get this out of this housing without undoing this. Next, I've got to remove this clutch. Before I go any further, I want to show you something else. If you look at these magnets here, before you take this apart, if you rotate this and you look at the magnets, if there's any evidence that they've been rubbing up against here, okay, then that's a good indication that you've got a problem with the bearing. And I'm actually going to, hopefully this will show up, but if I take this flywheel and I wiggle it, don't know if you can hear that or not, but there's excessive play in here. And sometimes when you turn this, sometimes you can actually hear like a clinking sound. And what that clinking sound is the apparently the bearings in these saws use plastic races, and the plastic races can actually break apart and fall into the crankcase, and you can actually sometimes even find pieces of plastic inside when you take it apart. But once that happens, the balls are allowed to just kind of clang around against each other, and you can sometimes hear them, and they'll make a clicking sound. And then of course this play will be excessive. This doesn't seem bad enough to maybe be the cause of it might not be, this doesn't seem like enough play to indicate that the races themselves are completely trashed, but this could definitely cause a problem with sealing. So we're going to get a look at those crankshaft seals when I get this apart. Not even going to bother doing a leak down test. There's a special parts that you can actually attach to this to seal off these ports and allow you to do a proper leak down test. There's actually Stihl part numbers for those. I was going to basically just come up with some other way to work around that. I was going to maybe make just a plate that I could attach to this. But rather than go through the trouble of doing all that, I think I'm just going to skip just directly to replacing the crankshaft seals. Alright, so what the heck, you know what, let's pull off this flywheel while I'm on this side. I'm just going to put a socket with a breaker bar on the this side of the crankshaft, and then I'll be able to should be able to loosen this. And when the saw is normally operating, this is the direction that the crankshaft revolves. So this nut is going to screw on normally. So this is a regular lefty-loosey, righty-tighty. This one, on the other hand, because of the fact that on this side we're actually going this way, okay, what would happen is if this was a regular thread, it would have a tendency to want to loosen from the torque of the saw running. So this is actually a reverse thread. So you got to keep that in mind when you're taking this off. And I'll get to that momentarily. Now I might need a puller for this, but just for the heck of it, now it actually looks to me as if the way this is designed, that if I take the ignition coil out, I can actually shift this back and take this out without having to pull the flywheel off at this point, which is going to be helpful because I really can't get a puller behind that flywheel the way it's in here. There might be a special puller that is used for this job. I'm not sure, but since I don't have it, I'm just going to pull these two little bolts out. Now this bolt right here goes through two electrical connectors, eyelets, okay. This one on this side has a washer, and now with those disconnected, the whole we get this 1/4-inch connector right here, spade lug. Pull that off, and really it's just a magnet holding it in. Move this out to the side for now. Alright, so now that's, yep, that's going to free up this side. I think I can get this out this side like I just said. So I guess I'll take the clutch off. Oh, so these studs just are held in by open-ended areas in the block, so I could just pull these out and get these back out of my way. See how tight this is. Now remember, this is reverse thread, so I need to try and turn this tightening, and then of course the problem is crankshaft just wants to turn. So the trick is how how do I get this off? Well, one trick is to remove the spark plug and put some rope down in there. Alright, so if you don't have an impact driver, what you can do is you can take out this spark plug, cut yourself a piece of like nylon rope, like clothesline rope, and feed it down into there. Of course, leave yourself off enough excess out so you can pull it back out again. But you feed enough down in there to fill that space above the piston so that when the piston comes up to the top of the cylinder, it can't go any further, and that'll effectively stop this from moving. And then you can actually put a breaker bar on here. And again, this is, you got to tighten. The direction you would normally go to tighten is how you want to go to loosen this. That way, the cushioning of the rope in there will keep that piston from being damaged, as opposed to like if you just stuck something metal down there, which would be a bad idea. But I found on my last saw where I took this off that I was able to just use the impact driver to spin it right off like that. A lot quicker and easier than going through the motions of that feeding the rope down in there. Alright, so we got this little disc that's got a little bump out on this side. I just want to make sure when I put this back on, the concave side is facing the long block and the convex side is facing out. It's at the center, it's got a little convex area. So this little wire thing right here, and that outer clutch cover sprocket thing is on there. It actually turns this, and this actually drives the oil pump. So you can actually see right there, that's the black hose right there coming into the bottom of the oil pump right here. Okay, that goes through a hole. That's this hose right here and goes right over to the oil reservoir. So I should be able to pop that off of a barb fitting right there. And then coming out of the top of the oil pump right here, there's what looks to be like almost like a 90-degree fitting that comes out and goes right over to here and attaches to the body. And then that forces the oil out through here, and then that makes it come out this hole right here, fill this galley, which normally would be on the back side of the bar. Oh crap, broke a wire. This wire right here that I disconnected, actually it's captive. It's pushed into a space between these two plastic parts right here, and because it couldn't move, I broke it off of its connector on the other end, which is right there. Son of a gun. Alright, well, I just got the whole long block to separate from the top, which is not what I wanted to do. Here's a screw right here where this wire hooks onto the block. That must be the grounding point, so I might as well take that off so that I can remove that whole ignition coil. There's the one I broke off. Good news is that's just a couple of eyelets. That'll be an easy thing to remake. So get this ignition coil out of the way. So I could pull this whole thing right off right now. That'll leave this whole crankshaft and everything left behind, which I didn't want to do. So let's work the problem. I'm going to guess at this point that maybe I need to take the oil pump off. That might be what's holding this in there. I see two screws here that look like they might hold the oil pump in. So I'm going to pull this little worm gear, the driver for the oil pump. I'm going to pull that out. Oil pump housing. Now we should have enough leeway to get this out. You son of a gun. Okay, flywheel has to be removed before you can do this. That's what I've just come to the determination. I'm trying to just drive this out with this plastic hammer. That's not going to do it. Okay. I'm going to pull this long block assembly off. Okay. I'm pretty convinced that this flywheel has to come off before this will come out of here. Just know how the hell I'm supposed to get a puller in there. There's so much crap inside here you barely can tell that I cleaned it. Alright, here's the new plan. Take a short bolt, run it into the nut that I took off of the flywheel part way. Screw this down onto the crankshaft end. Okay. So now there's a gap. The flange nut is not all the way up against the flywheel. There's a little bit of a gap in there. It's not screwed on all the way. Alright. Support the crankshaft and give it a good wrap. Couple wraps. Take the tool off. Flywheel removed, undamaged. Alright, now with the flywheel off, the bottom half of the long block comes right out. I can take this disgusting mess over to the parts washer. So it's clear the way that this goes back in. The sprocket side has these two holes here for the oil pump. So I'm going to pop this out. I'll clean this up in the parts washer, but I don't see any visible cracks. That's good. Boy, that seal feels... This seal feels really loose on here. This side feels not too bad, actually. But this side here is really, really loose. Take that seal off. Wow. Gee, I would have thought that'd be a press fit. That seems weird. That comes off like that? Isn't this supposed to be a press fit? Who am I talking to? Alright. I'll take this seal off of this side. And that is pressed onto there. Why is that one not? That's weird. I think I'll clean up all these parts for visual inspection. Well, time to do a little assessment and, more importantly, some soul searching. Oh, this is one ugly piston. You know, it didn't look too bad until I cleaned it up. Now you can see all of these score marks, and it's actually, I can actually feel it with my fingernail. It feels like a ripple. So that piston, I can't believe that this thing tested so high with compression. And if I feel with my finger at the edge right here, I can actually feel almost like a ridge of distorted metal. This side doesn't look much better. There's actually one spot right here where the piston managed to survive. So that's what it should look like. And over here is like really bad. There's a really bad score mark right there. You can actually hear. As opposed to if I try to do that here. So I need a new piston, and right about now, some of you guys are probably going, well, yeah, don't even bother. Just get a whole new cylinder and piston assembly. And then some other guys are like, no, just get a whole short block. Well, the cheapest short block on eBay is like 65 bucks. But that gets you the cylinder, the piston, the connecting rod, the crankshaft, new bearings, new seals. But it's a cheap aftermarket Chinese. But a lot of guys are saying those. Oh yeah, listen to this bearing. This one is the one that slides right on and off of here like this, which I don't think it's supposed to do. And there's actually there's almost an indication here. There's a rub mark right there. Almost appears to me like maybe this was spinning on this. The seals, took both seals out, cleaned them up. So if I put this seal on here, it actually doesn't feel too bad. Okay. Take this seal, same side, a lot looser. Okay. You have to trust me on this since you're not here, but this is sloppy as hell. Let's try it on this side. So on this side, pops on and off easy, although yeah, I am past the taper, so it should. Whereas this one, see, it grips a little bit. Okay. So I think this crankshaft seal is toast. So I'm having trouble deciding what I want to do here. I know I'm looking at, I'm gonna do bearings, and I'm gonna do crankshaft seals, and I'm gonna have to do piston and rings. So the question is, do I want to do that only, or do I want to also go cylinder assembly? Well, I tell you what, you know what's going to help decide that? Let's look at the cylinder. Guess I shouldn't be surprised. Cylinder looks pretty scored also. This side doesn't look as bad. This is kind of interesting to me. This actually says 1127-029. I wonder if 029 was an old Stihl model number that, because I know there were some model numbers that ran like that. I wonder if 029 was the predecessor to the MS290. Hey everybody, it's the next morning. I actually spent a good amount of time last night on the internet reading through different forums to get opinions on different things, and also trying to formulate my plan of attack for what I'm going to do for replacement parts. So first let me talk about crankshaft bearings. These crankshaft bearings that are used in this saw, in this particular model, this MS290, the clutch side bearing and the flywheel side bearings are identical. The reason why I mention that is because on some models, the bearing on the flywheel side is one way, and then the one on the clutch side is a different way, different size, I should say. Anyways, the important thing about my particular saw is that these two bearings right here are just regular old 6203 bearings, which is a standard bearing size. You can take a 6203 bearing and you can buy this bearing in any number of different configurations from any number of different manufacturers. Now, I had read online, actually I saw in a video where a guy tore down one of these saws because the bearings had failed because the races were plastic. So obviously it shouldn't be hard to upgrade to a better bearing than something that has a plastic race. These particular bearings, they're marked 6203 C3. C3 defines how much clearance the bearing has. Higher precision bearings actually have a different designation, like C7 for instance, or C4. And the problem with those bearings is you actually don't want something like that in a high RPM situation where there's going to be a lot of heat like a two-stroke engine, because what will happen, or what can happen, is as the dimensions inside the bearing increase, as things start to grow in size because they heat up and expand, you can actually have it seize. So you want to stay with a C3, and that's been confirmed by several people in the know on the internet who've experimented, I guess, with different bearings. But the important lesson to learn here is that if you buy genuine Stihl bearings for this saw, you're going to pay quite a bit more because they're going to be from an OEM Stihl dealer, and B, quite frankly, the bearings you get might not be any better than these here. These are made in Turkey, but I can't quite make out the manufacturer on these. My point is, though, you can get Timken, SKF, Nachi, FAG, any number of different companies out there that make a good quality bearing that'll fit right in here. The 6203 designation just means that it's a 40 millimeter OD, it's a 17 millimeter bore, and it's a I forgot what the width is. But anyways, you can just look up a 6203. And if you go on eBay, lots of times on eBay you'll find new old stock bearings from really good companies like SKF, for instance, and you'll find that they'll have like really cheap prices on them. Now, a word about those new old stock bearings. If it's a sealed bearing that has a sealed lip on it, we're just talking about for the sake of if you're thinking about buying bearings for something else, if it's got a seal on it, that means it's preloaded with grease and it's sealed. On old bearings, I've heard that there can be a concern with the grease being kind of coagulated or not really in good shape after years of sitting in there without being used. This is a unshielded, unsealed bearing. It's just wide open. This bearing by design is supposed to allow the oil to get in there and lubricate this bearing as it's running. So you do not want to put a shielded or sealed bearing in place of one of these bearings. Okay. So you should be able to go online, and I found last night for like $6, $6.50 a piece, I could get some really good quality bearings for this thing. And I was going to do that, but before I bit the bullet and bought those, I moved on to the next little slice of heaven, which is these seals. Now these seals are interesting. These seals are marked right on them, Stihl, but they have a very unusual part number on them. And the part number is a BAFSLDRWX7. And if you run that part number through Google, you cannot find that part number. You can't get that part number to come up on any U.S. websites. It's all foreign. And they all lead back to the same place. They lead back to a bearing manufacturer of automotive type bearings in Poland. So my theory is that these were made for Stihl by that Polish bearing manufacturer, and that part number I just gave you is the original part number of the bearing, and that Stihl then puts them and gives them their own Stihl part number. So these are just a regular oil seal. They're made of a material that is resistant to oil and to deterioration from exposure to oil and gas, which makes sense. Nothing really special about these seals, except for the fact that they have an unusual dimension. They actually have a dimension. The OD is 30 millimeter. That's not a problem. But the width is 4.4, and it's actually marked right on here. 17-30-4.4 is a reference to. I already checked it with my calipers. Sure enough, 30 millimeter, 17 millimeter bore, 4.4 millimeters thick. And interestingly enough, I read, when I was reading about the pros and cons of these aftermarket kits for replacing bearings, for doing rebuilds on these saws, one of the complaints I noticed was that somebody had mentioned that the seals that came in their kit were too wide. Well, that's because the 17 by 30 by, I believe, 5 or 6 millimeter is a much more commonly found seal size.
So my theory is that the people who were buying those particular aftermarket kits were getting seals that had 5 or 6 millimeter widths, and that's why they were a little wider. Now, you might still be able to use them. The seal would stick out a little bit proud of the case, but probably still work perfectly fine. Not positive about that, and I'm not going to worry about that right now. So you're basically stuck in a situation where if you want to get these seals, you either buy the OEM steel ones and pay, more money. And for some reason, if you buy the seals separately from Stihl, they're more expensive. But if you buy the whole gasket kit, you get the seals in the kit. And there's a whole discussion about whether or not that's true. Long story short is I was going to have to go elsewhere. I found these seals for as little as $1.48 a pair on one website. But it's a website that's basically, it's a Chinese manufacturer that manufactures a lot of these aftermarket parts. So I thought to myself, well, I'm going to have to wait longer than I want to wait to get these seals from China. And they're going to be, well, Chinese quality, which may or may not be any better or worse than these here. So then I was like, well, I got to buy either a piston assembly, okay, and then hone this cylinder, which I don't have a ball hone for this size cylinder. And if I go to my local automotive machine shop, there's a guy next door to him who does motorcycles and ATVs. He can do a hone on this for me. But then I started looking at just the price of complete cylinder assemblies with a new piston and rings, and it was like you can get for like $20, $23, you can get this whole cylinder assembly with a new piston. So then I started looking at some of the other kits, and I ended up finding a kit from another manufacturer, and there's different variations of these kits, but I actually ended up settling on a kit that I think for like $35 I get a new cylinder. This is all cheap aftermarket stuff, I know. New cylinder, new piston, 2 new bearings, 2 new seals, and they even throw in a new fuel line, a new oil line, an oil filter, a fuel filter, I think a spark plug, a couple other little, doohickeys. So at this point, it's like, I only paid $70 for the saw. I don't want to dump a ton of money into it. I could buy OEM stuff, and by the time I get done, I've got like a brand new saw, but quite frankly, I've got so much money sunk into it, why not just have bought a brand new saw, right? So that's what we're going to do. We're going to wait for this. We're going to wait for this kit to come in from, actually, supposedly it was a U.S. seller. So even though it's a cheap Chinese kit that supposedly it's stocked here in the U.S., this should be in next week. And then when that comes in, we'll start putting stuff back together and see if we can't make a good running saw with a cheap kit. So I ordered this kit from a seller on eBay known as VO Store. And this is the 46 millimeter cylinder piston kit, they're calling it. And that's what it looks like. There's what the cylinder looks like. There's what the cylinder and the piston and the rings look like. Wrist pin. And it looks like it comes with 2 bearings, 2 seals, fuel line, fuel filter, oil filter, a spark plug, pull handle for the cord, air filter assembly. Not sure what that is. Oh, all right, it says so right here. Cylinder piston kit, 46 millimeter. Piston pin bearing, air filter, air seals, crankshaft bearings for both sides, spark plug, oil line, fuel filter, starter handle, and the starter pulley. Starter pulley? Plastic? Yeah, I didn't even notice if it was plastic on the one I have. Oh well, not worried about that. All right, so now we're going to see how well the quality of this kit is and how good the service is here with this company. Now, this seller's feedback rating is 98.9%. So, it's not perfect, but then again, we get 61,000 feedbacks. So I look at eBay's handy-dandy little chart here, and you can see in the past month they've gotten 1,264 positive feedbacks, which
That's actually quite a bit, considering, I mean, not everybody leaves feedback. People buy things all the time and don't bother leaving any feedback. 10 neutrals and 18 negatives. So if we click on this, we could see what people are upset about. All right, so this is, see, for some reason, this doesn't always show up, but like in this case here, we can actually see what this is, because it says fit perfect, but would not work. The ears would not come out to turn engine, so that must be a pull starter assembly for something. Poor communications, took forever to get my money back after package didn't show up. Lug nuts were loose in the box, hitting each other all the way. Horrible service, paid extra for shipping, never got the item. A lot of people not receiving their product. Well, I guess we shall see how good the shipping is. I ordered it last night, so the evening of April 16th. I got a notification that the item has been shipped, but when I track it, it says that the label's just been generated and they're waiting for it to be picked up. So hopefully we'll get an update saying that it was picked up for shipping by the end of today, although it's already 3 o'clock in the afternoon. Worst case scenario is if it goes out tomorrow, I would still say that's reasonable. If it's still not left their location by then you got to wonder whether or not they're having inventory shortage problems or just not on the ball. All right, I guess that's going to close out this video. I'll probably close this video out right here because I think it might be at least a week probably before I can get back to this, unfortunately. So wish me luck.